For generations, humans have fantasized about the ability to communicate and interact with machines through thoughts alone, or create devices that can peer a person's mind. This is how brain-computer or BCI comes about.
A brain-computer interface is a direct communication pathway between the brain and an external device. They are often directed at assisting, augmenting, or repairing human cognitive or sensory motor functions.
Users manipulate their brain activities instead of using motor movements to produce signals that can be used to control computers.
Every human brain is filled with neurons with individual nerve cells connected to one another. Basically, this technology is based on sensing, transmitting, analyzing and applying the language of neurons.
It is not until the advances in cognitive neuroscience and brain imaging technologies that started to provide us with the ability to interface directly with the human brain, an idea that has existed many years ago.
Hans Berger, inventor of the first human electroencephalogram or EEG, demonstrated the technique for recording the electrical activity of the human brain from the surface of the head in 1929. This laid a foundation for brain-computer interaction.
Early BCI systems began to emerge towards neuroprosthetics applications that originally aimed to restore damaged hearing, sight and movement.
Researchers started using animals like monkeys and rats to test out these systems. In May 2008, at the Pittsburgh University Medical Center, monkeys have navigated computer cursors on screen and commanded robotic arms to perform simple tasks simply by thinking about the task without any motor output. There are two main types of invasive BCI. Electrocorticography or ECOG is done by placing a network of electrodes on the exposed brain surface. Intracortical interfaces are microelectrodes inserted directly into the cortex of the users. Invasive BCIs can be used to restore movement in handicapped people.
As of right now, there's nothing to cure paralysis, besides maybe a miracle.
I got to use a robotic arm for the first time, and I got to reach out and touch somebody for the first time in 7 years. That was my highlight, absolutely.
Both methods are considered the gold standard technique to extract brainwave signals. However, these procedures are invasive, therefore making them risky. Only a very small area of the brain is being monitored by an intracortical interface, and an even smaller area of the monitored area will be delivering a stable signal. Signals can also get weaker or even non-existent as the brain tissue reacts with the interface. Positively, a small area also means that intracortical interfaces are able to deliver very localized and focused readings, making it particularly useful in studying a certain area of the brain.
One such non-invasive BCI is an EEG.
EEG is quite a different technology to functional magnetic resonance imaging. With fMRI, we're measuring the flow of blood around the brain, the regions of the brain that work hardest, draw the most oxygen delivered through the blood, and that's what we're measuring. With EEG, we're measuring the electrical signals that come from the neurons in the brain. Now that sounds a little bit scary, but really it isn't. We're not putting anything in, we're not doing anything with these electrodes other than measuring what's going on in the brain. And we can use that to determine which parts of the brain are responsive at particular points in time.
Two research areas are interface design and entertainment.
Here the user plays music. Please select the music application. Please select the Vorta. Pause the music. Resume the music. Go back to the application selection. In this scenario, we demonstrate where the user communicates using our BCI system. Now he will express that he wants to eat fruits.
Can I have some fruits?
Now he will express that he wants to change his clothes.
I want to change my clothes.
Farewell.
EEG has lower costs as compared to invasive type BCI, and non-invasive at all as it is worn on the head. It also does not require a motor response by users in order to send signals. However, EEG has a low spatial resolution and cannot accurately tell the exact location of the brain activities. Furthermore, only the upper layers of the brain are readable.
Beside medical and entertainment purposes, BCI can also be used as a fashion accessory.
An artistic tool.
to control unmanned vehicles.
This remote-controlled robot with a nose-mounted camera turns right and left, moves up and down, and even flies through a ring, all on commands from a controller who uses a special instrument. And what is this instrument? The controller's mind. Here at the University of Minnesota, Professor Bin He and his team have engineered a non-invasive system called a brain-computer interface that allows a person to control a robot using only their thoughts. Dr. He's team includes Alex Dowd and Carl Lafleur.
For example, if you imagine making a fist with your right hand, it turns the robot to the right.
And if you imagine making a fist with both hands, it moves the robot up.
Here's how it works. When the controller imagines a movement without actually moving, specific neurons in the brain's motor cortex produce electric currents. These currents are detected by electrodes in an EEG cap, which sends the signals to the computer. The computer translates the signal pattern into a command and beams it to the robot via Wi-Fi. In this case, turn right.
This brain-computer interface technology is all about helping people with a disability or various neurodegenerative disease to help them regain mobility, independence, and enhance performance. We envision they'll use this technology to help control wheelchair, artificial limb, or other devices.
This has tremendous potential for people who can't move or speak. And the best part is,
it's completely non-invasive. Nobody has to have a chip implanted in their brain to pick up the neuronal activity.
We're very proud to have taken this step towards that goal.
Or even for communication.
Yes! Success!
The potential of the BCI is infinite, and it's only limited to the imagination of the human mind.